Hi and Assalamualaikum. My name is Luqman Nur Hakim bin Zainal. So today our group, which is group 6, will present to you about the coconut pulp shaver. So this is our group member. Firstly, Nur Khairan Syahmi bin Nordin, MA 21121. Muhammad Haikal bin Muhammad Rosidi, MA 19085. Tengku Muhammad Ikhwan bin Tengku Zahwin, MA 21127. And me, Luqman Nur Hakim bin Zainal, MA 21136. So we will move to the introduction.
Assalamualaikum. My name is Instrumentation. My chemistry M8211121. We present the introduction of our project. This project to create the instrument system to collect transductor data, analyze data in time and frequency domain using DC lab program software. We choose to measure the acoustic product through a coconut plum shaver. Our objective to analyze the sound wave from coconut plum shaver to interpret the signal into time domain and frequency domain. Our scope of study: coconut punchable will be used to create a sound wave. Microphone will be used to detect the sound wave. The sound wave will be observed by using the C-lab. The performance of the microphone will be analyzed by comparing it with the cyber app from a phone. Microphone. A microphone is a speaker and a sound system which converts sound wave into the electric symbol. Its signal can be amplified as a direct signal or modified to an amplified signal that can be programmed via a PC or other electronic sound system. Receive. An electrical sensor acoustic receive or transductor detect and convert sound signal to electric symbol. Different type is also a movable plate with a material vibrating sound wave. Microphone sensor. A speaker is a sensor or transducer that change electrical signal. Division between the plate is modified at the time when the moving plate vibrates with sound wave. The change is capacity can then be converted into electric signal. Sound sensor. Consumer hardware such as a phone, computer, and music player. Security and monitoring framework such as alert, anti-alert, and other similar features.
Assalamualaikum and very good day. My name is Muhammad Haikal. I will present about literature review. The first is acoustical measurement and instrument. Acoustical measure are the quantities that define sound and noise in terms of their intensity and qualitative characteristic. Sound pressure, sound intensity, vibration velocity and particle displacement, vibration frequency and period, propagation velocity, damping factor, and other acoustic variables are measured. There are numerous methods for measuring and evaluating noise, each of which produce distinct noise measures, descriptors, and scales. Criteria for determining the acceptability of noise levels for various activities has been devised using this metrics and description. These criteria can help determine whether noise reduction initiative are necessary to improve verbal communication, reduce annoyance, and prevent sleep disruption. The goal of acoustic noise measurement is to provide objective physical noise measurements that can be compared to predetermined criteria in order to judge its acceptability. To ensure the quality and uniformity of the measurement procedures result, they are subjected to national and international standards of varying severity depending on the application. Next, literature review about microphone. Microphone is a device that converts sound wave in the air into electronic impulse and record or broadcast them over the loudspeakers. Microphone can be used for a variety of purposes, including music vocals, speech, and sound recording. Microphones can be used on their own or in conjunction with other devices such as headphones and phones. The dynamic microphone, which is the most popular variety, employs a coil hung in a magnetic field that can be linked to numerous membranes for increases frequency response. The audio signal is produced by dynamic microphones using electrical energy in the form of induction. The mics are ideal for live performance. Tiny diaphragm is coupled to a moving coil in the microphone's capsule. The diaphragm vibrates as sound waves strike it. The coil in the magnet field moves back and forth, generating the electrical current. Next is frequency response. The frequency response of the microphone describes the range of sound it can reproduce and how its output varies within the range. The frequency response for a microphone is the most important aspect in determining its sound signature. The response curve graphically depicts a microphone's frequency response. Flat response and sharp or customized response are the two most common varieties. The response curve of a flat response microphone is almost flat because it is equally sensitive to all frequency range. The sound source is properly reproduced by a flat response microphone with a little or no change from the original sound. That's great for recording musical instruments or sound effect, but a flat response mic isn't ideal for recording voice. Some frequency ranges are more responsive to a sharp response microphone than others. It features peak and valleys in its response curve. When a microphone with a curved response is mounted on the stand, it is less sensitive to low frequencies, which minimize the pickup of both handling noise and stage rumble. A boost in the upper mid-range, usually between 3000 and 6000 Hz is also indicative of a sharpened response microphone. Presence rise is a technique that improves the clarity or punch of voices and instruments. Lastly, coconut palm shaver machine. A coconut grater with a rotatable shaft and a plurality of curved grating members is used to grate and remove the coconut flesh from the interior of the coconut shell. Each grating member has a front section that is attached to the shaft's leading end, and then curves outward and backwards to extend in a spacious relationship with the shaft. At a place rearwardly spaced from the leading end of the shaft, the numbers of angularly spaced struts extend radially from the shaft. Each grating component has a back portion that is attached to at least one of the struts, as well as grating edge produced by small apertures with sharp edges that protrude externally.
Assalamualaikum warahmatullahi wabarakatuh. I'm continuing to present audio which is methodology. So this is our materials and equipment for storing grinder machine, some meter, meter app, laptop, software, the lab. And the lab setup, we use this type of module. And then we adjust the measurement setup and general setting. The sampling rate is 10 kilohertz and the block size 20,000. And then to get the decibel value, we record the sound using the sound meter app, and the data that we get current decibel 90.8, average decibel 90.4, and then is the formula that we are use. So to get the value, we substitute the dB value that we got from the sound meter app, and then the V value from the digital meter. So after calculating, so the formula that we got, and then insert to the formula interpreter. After that, we run it again, and then this is the decibel value that we got, which is 90.4. That's all from me. I will pass to the next presenter. Thank you.
Okay, now I will present the result of the project. So if you see the first picture, which is the RMS value is 0.24 volt. The decibel value is 19.4 dB. So what we get in our smartphone sound meter apps, which is 19.8. Then the percentage of error is only 0.44. So it's very accurate for me for this project. So next, this is our time domain graph and frequency domain graph. The voltage fluctuation from -4 volt to 4 volt over time. The graph, despite the greatest and smallest amplitude in volt. Voltage with the time, as can be seen, change audio frequency has no effect on amplitude. So we perform FFT, fast Fourier transform waveform analysis in the Daisy Lab setup, which here in a figure time domain graph. We discovered the biggest frequency peak at, I'm sorry, not a time domain graph, which is a frequency domain graph. We discovered that the biggest frequency peak is at 250 Hz. We can observe from the graph that the frequency domain graph contains a lot of noise, which has a great lot of distortion. So if you see the time domain graph, the peak of this graph is 2.95 volt, and the peak of the frequency domain graph is 0.86 volt. So now for the conclusion, we learned how to use Daisy Lab software, which will come in handy in the future. We now have a better understanding of the key component in the measurement and instrumentation process. We applied our subject knowledge to complete this job because we must utilize formulas to determine decibel levels. This project is significant because it's in our knowledge of what we have studied in class this semester. Finally, there is some disturbance or inaccuracy because this project was conducted at home. The source of the disturbance could be environmental noise. This project should be conducted in a confined facility such as a laboratory to exclude outside noise from the environment. This research showed how to build a time domain and frequency domain signals analysis and comprehension system. So I think that's all from our group. Thank you.